Coming back. My name's Hardy Pottinger. I promise not to say spec anymore, if you remember from yesterday. And I wanted to, oh, sorry. How about that? Excellent, okay. To start off, I'm not gonna read a poem, but I did want to do a little bit of mindfulness, mostly for me. I'm gonna take a deep breath, and anyone wants to join me, that's cool. You don't have to, don't feel pressured to do that, but I'm gonna take a deep breath right now. Can you hear me now? Yes? Awesome, okay, I'll stand very close. All right, today we have breakout sessions and a poster session coming up this afternoon. There are flip charts outside the room to put down, so put down your breakout session ideas. I believe you all have already been doing that. The community support volunteers for the afternoon are Aaron Fahey and Bobby Fox. They're located in the back of the room and have zebra-striped lanyards. The online community support volunteer is Francis Kaiwa, K-A-Y-I-W-A on Slack. And we would like to thank our silver sponsors, Ex Libris, Protocol Labs, MIT Libraries, and the generous folks at LibTech Women who offered a matching fund for the individual donations to our diversity scholarships. And next up, we have our 20-minute talks, and our speakers are out in the audience somewhere. You guys can approach the stage, that would be awesome. First up, we have, you know, they might not be here because it's, I'm ahead of time. Anyone want to do another?
We're right here.
Awesome, great. I was gonna. So first up, we have Sherry Fu and Shalini Ramachandran and Stephen Cutchin, or just two of you. Algorithm bias study is the name of their talk.
I've been abandoned. That's all right, she'll be back in a second. Those lights are very bright.
Great. So one of the benefits of being early, you can forget things.
Have to use the mic.
Use mic. Can you? Is this better? Yes.
Go ahead. How do we?
We're,
I'll try and.
Give us a second while we figure out what we're doing.
There we go. I wasn't actually involved in the study. I was just tech support the whole time.
So welcome. In the next 20 minutes, we'll tell a few stories, share some data, and look at the future. And we'll answer a few questions. Steve and I are here to present, but this presentation is a result of teamwork. So these are all the people in our team. Our two colleagues, Shalini and Karen, who are not here today, are amazing scholars who also made this research possible. We have a pretty standard presentation, introduction, study findings, credits, future, all that good stuff. So we'll start with the operational definitions and narratives about the harms of bias, specifically racial and gender discrimination and social and economic losses. Algorithms are sets of instructions within computer programs that direct how these programs read, collect, process, and analyze data. They are part of the architecture of much of the internet and are also the basis of artificial intelligence and, of course, search engines. Algorithm bias occurs when computer algorithms systematically discriminate against certain content, individuals, or groups in favor of others without a sound bias. We, led by Steve, came up with this definition because we like it because it uses plain language, and we wanted to use it to have thoughtful conversations about this topic. So as an exploration of how to remedy algorithm bias, we ask ourselves as educators in higher education, as librarians, and as information professionals, how important is pedagogy that raises awareness about database design? So this question has many facets. education, technology, social justice, ethics, and philosophy. Frankly, we chose this because we care about applied standards of right and wrong. And specifically, from a practical standpoint, as educators and as professionals, we ask, could pedagogy that raises awareness about how databases are designed by humans with pre-existing biases be an important part of how librarians teach information literacy? So this question, among many other questions, was raised at USC. At USC, I learned about the topic and met the various members of our research team. Sophia Noble, also teaches at USC, spoke to librarians about racism in search engines in her 2018 book, Algorithms of Oppression. And she starts her book with examples of the harms of bias. So one example of both gender and racial bias are the search results she found in Google after she typed in black girls. Most of the results were pornographic and offensive. And the clicks of users on these results, along with prioritizing paid advertisements, mean that biased and disturbing representations of black women are replicated online in Google. Because Google is effectively an information monopoly, it has tremendous power to prioritize results. So last month, I heard a new joke at a presentation. Where do you hide a secret on the internet? Anybody know? All right. On the second page of a Google search. But jokes aside, the book concludes with an interview about the harms of being invisible on the internet in another platform. Candace runs the only African-American hair salon in a white neighborhood. Her business has changed a lot since the internet grew and demographics have shifted. She became invisible and had to pay to play buying advertising in Yelp. She paid to remove her competition at the bottom of her salon page and in search in search results, and to be more prominent in search results. Yelp also selectively blocks reviews to further minimize her presence. It looks like she doesn't exist in her neighborhood. She can't find her own salon. Candace summarizes, the key is to be independent of these companies, because they will never stop. You just can't negotiate. So these examples show the harms of bias for African American women and small businesses. Obviously, it's a much bigger problem in need of appropriate solutions. Noble and others call for search engine transparency. Other advocates call for government regulation to address the issue. We also see education as a long-term countermeasure. So we wanted to know what the future information architects and computer scientists thought.
I'll use the space bar. Okay. So I'm Steve. I did the, so based on that motivation and getting involved in this, we went out to ask computer scientists, specifically students being trained to become computer scientists, about their views and impressions of algorithmic bias and search bias. The study involves students at 3 different institutions: the University of Southern California, Boise State University in Boise, Idaho, and Cal State, Los Angeles, California State University in Los Angeles. We've got and these are our initial preliminary results that we're going to go over today. We've received initial results from the University of Southern California and from Boise State University. The survey questions are still ongoing at Cal State LA, so we don't have that information in at the present time. One of the reasons that we picked these different institutions, obviously one reason was we were all there, that was helpful. But one of the other reasons was that they're pretty different from each other. Boise State is in a mixed rural-urban environment with a predominantly undergraduate student body that's demographically homogeneous. There's a large segment of it that is students returning for second degrees that is very highly represented. University of Southern California is a highly metropolitan urban environment with a large population of undergraduate, master's, and PhD, as well as domestic and international students present inside of it. And Cal State Los Angeles is a very relatively to Boise State, a very diverse environment that's heavily Hispanic serving institution. So we're very interested in what the results from that area will be. So we tried to ask a broad swath of various differences. And as you'll see from some of the results that we have received so far, that difference is that there's a difference there. It's showing up in the results. That's what I'd like to say. So one of the biggest results, it was a definite and dominant result that we got back from our survey across all of it. 93% of all respondents to the survey agreed that AI algorithms will improve over time. This was universal and stood out across all of them, so which we think is pretty significant. It's not, but what does this mean other than that the university's admissions programs are only admitting optimists? Okay, that seems, but that is a pretty strong bias, that you expect the algorithms to improve as you move forward, almost no matter what. It's pretty close to a faith-based decision on these people, on these groups' part. This gives rise, at least experimentally, to what we've seen so far in that, oh, we'll fix it later. The program will fix it later, even as they move forward with the work that's being done presently in their study and in what they're learning. The other, on the other hand, at the same time as they hold this belief that it will definitely get better as they move forward, 89% of the student respondents agree that engineers can create biased algorithms as they develop these solutions. Everywhere from 79% includes somewhat agree, and strongly agree. That's a pretty strong, reliable, consistent response as well amongst all survey participants. We think this opens up a lot of questions about, well, if you really, how do you, at the same time as you argue that they're just going to keep getting better, but this group who makes them can make bias into the algorithms, how do you resolve the little bit of a conflict between these two things as we move forward, and how do we discuss it, and how do we bring it up for engagement? Shouldn't you know about this disparity in the courses that you're teaching? A lot of our preliminary results have identified areas that we want to find more we want to ask more questions. So what are the types of questions that we asked? We asked, these are 4 questions that we asked them, and amongst various other ones. We specifically asked them agree or disagree, everything from strongly agree to strongly disagree, with everything between on a scale. Search engine results are good enough for everyday questions. Search engine results are accurate. Students are trained about the ethical impact of algorithms, and the basic question of, are algorithms biased in the result? And we were pretty picky about that when we were asking, are the algorithms biased, not the people who use them or the systems that use them. We wanted to know if, as the algorithms become more and more complex, do you see bias in the algorithm itself? And we got some pretty consistently reliable results across all the participants. All right, so these stood up at both institutions that we've received results so far. 96% agree that search engine results are good enough for everyday questions. So this indicates pretty strongly that if we were in the marketing world, we would argue that they're very happy with the results they're getting from their search engine, which implies that they're not going to be examining it for bias or untoward behavior or issues or problems or anything like that. It's meeting their needs, so they're going to be saying it's great. It's going to be difficult for them to conclude that there's bias in it based on their utilization of it. 82% of respondents agree that search engine results are accurate. So some are questioning the accuracy of it, even as they agree that it'll work, it's good enough. Most of the variety of them think that it's good enough. And 69% think 69% of the respondents believe that students are trained about ethical impact of algorithms. That number seemed high for everyone's experience to put the study together. So 69%, based on our experience with these particular group, that 69% of the students in these programs being trained about the ethical impact of algorithms doesn't match very well. It seems an overestimation compared to what we had discovered in both literature survey and our experience at our different institutions as well. So we have more questions about that particular and 57% agree that algorithms are biased. So if 96% agree that the systems are good enough for everyday questions, but 50% agree that the algorithms have bias, that should lead us to conclude that a large number of respondents are compensating for that bias when they get their search result in some fashion, or subconsciously doing something to mitigate against it. Because if you're using a search engine and you believe that there's bias in it, even though it's good enough, you have to be doing something to deal with the fact that you expect the results not to be as accurate as you expect it to be. So once again, though, we see a very strong pro-optimism, heavy, these are great, they'll get better, keep moving as we move forward. And the respondents were satisfied with the result. 56% have a positive opinion on search results being complete. So a larger percentage, if you ask them, is this an exhaustive list, is this a complete list, will say that no, it did not find everything that I would expect it to find in the process of doing the search. This brought up the question that we haven't had an opportunity to ask that seems important. Just exactly how important is trustworthiness of the search engine results to the students as they use it, as they go through their programs? And that is something we'd like to investigate further as we move forward and bring our results together. Finally, those are the preliminary results. We did notice one thing, one significant, so on the right, we have the University of Southern California results, the histogram results for 2 questions related to, is there discrimination in AI services? And on the top and on the bottom, we have USC students' response on, should there be government regulation in search engines? Okay. The same thing on the left is Boise State students' response to, is there discrimination in AI services? And the bottom is, should there be government regulation? Looking at the slide, the first thing that you can notice is that at both sites, they're almost as exact matches for each other. So the students who responded that they disagree that there's discrimination in AI services seem to be almost exactly identifying that there should not be government regulation in this area either. Now the results are very similar between USC and Boise State. Boise State, the combined aggregates and the averages are very similar across the board. There's a lot of commonality. But one thing that became apparent, and this holds up across almost all the questions, is that there's a very strong rightward skew for the Boise State respondents. All right, so the Boise State respondents were much more likely to select disagree with government regulation or disagree with AI services in relation to the questions that we ask. And this was pretty consistent across the board. Whereas the USC students would shaped a bit more like a bell curve. It's pretty widely distributed across, all the way from strongly agree to strongly disagree, with the largest one at neither. This held up across almost all of the questions for this difference between the 2 institutions. Now, it's a relative difference. Overall, the averages are very close to each other. It's modest, but it's a very clear trend between the 2 institutions. And we didn't have enough detail or questions to investigate if this skew of the result is based on, we'd like to investigate it further. Is it based on urban-rural difference? What's causing this difference? Is it urban-rural? Is it USC has a much larger international representation inside of it, and we don't have a distinction between that on these ones to decide if that's having an impact on it as well. And USC had a much larger segment of master's students responding versus undergraduate students, and we have questions as to what of those is causing the issue as well. But this they take the same types of courses, they learn the same technical material, they study and build the same engineering solutions, but there's a definite difference in their attitude towards algorithm bias and AI services between these 2 different institutions. And hopefully we'll learn more from the responses from Cal State Los Angeles.
And So that leads into our next slide. So things that we're planning to do in the future is to look at the data from Cal State LA, and also to, we've talked a lot about ambiguous data, and so we want to do interviews and have qualitative research to really figure out what's going on. And then the last thing we're going to talk about are instructional modules. So one way to remedy the situation is to think about how bias exists. And then we can create instructional materials and design them, and then test them and assess them. And we would get feedback, and we really care about data-driven empirical instruction. And so one way to think about it is to look at how Google is explicit about selling ad space. Some librarians do teach about the profit motives of Google, and they're one of the biggest companies to profit from user data, views, and interaction. Yesterday, Sarah Roberts mentioned that internet companies are businesses that really focus on customer advertising. Librarians could also create search literacy cases that recognize implicit bias and algorithms. And we can teach search skills and evaluating results, something that we already do. So making these biases obvious would mean using improved search engines, and hopefully they would make their complex algorithms more open and transparent. And all this is to say, in the end, we want users to feel confident in their information and their search results, that they're complete and trustworthy. So, and then to kind of wrap things up, my partner and I, we take walks past our neighborhood elementary school daily. One spring, they had a huge banner out in the front of the school. Every week or so, the banner would read what % of lunches were zero waste. Each week it grew, and at the end of the month, it was 100. So education tied closely to action is a really important place for us to start. We have 1 minute for questions. If anybody has a burning question or you just want to take more deep breaths, that's okay too.
You said that you wanted to dig into the part about 69% of students thinking that people had training on bias in algorithms. Do you have any sense, even kind of anecdotally, of what percentage of engineering students have to take like an ethics in computer science, or even not have to necessarily, but do take an ethics course in engineering or computer science?
So it's not far off. It's likely to be close to 50%, but definitely lower than the 69% that there. And it might be a little bit. There's a widespread adoption of the ethical requirement for undergraduate programs, and it's being pushed out pretty strongly, but it's still early. And if we draw a distinction between the ethics programs for computer science or engineering. While it may be 50% for those, almost none of those. The number that includes sections on algorithm bias is probably down around 25%. That's even smaller in the program. So I think the respondents are probably including the ethics courses that they had as fulfilling the requirement for being taught about algorithmic bias.
And we did a literature review, and we found one article, I think it was, that professionals and students, engineering students, both read the ACM code. It's a professional organization for computers scientists, and the two populations, they read the ACM code of ethics before taking a quiz on how to make ethical decisions, and their results were exactly the same. The ones that read the code had the same results as ones that didn't read the code. So we think there can be improvements in ethics education, right? And right now it's largely based on codes and case studies.
And then I had two, same
Yes.
we're right next to each other.
Over there, right.
I had two questions that are related to each other but separate. The first one being, what time frame did you collect this information from? Because I'm kind of curious to see if it was kind of before or after this conversation in the national media of fake news. And that's when we started, I think, in the larger population thinking about this idea of the news we see is being generally shifted. So there's that question. Then the other is leaning towards did you collect any data around the students' political leanings? Because I think you might also see some confounding variables there. Just thinking about the populations that tend to go to each of these universities, I think that's something to potentially look into.
The study was done in January of 2018, so very recent. After we began the study, we noticed a whole bunch of stories about algorithm bias being published, so we don't know if that was just us observing something we were involved in or if it increased or not, but it was certainly not it's not a before and after all the news coverage about fake news that was already ongoing as we pushed it out. I don't think we asked any political leaning question, and we would have been worried about prompting in their responses to shift one way or another if we'd asked those types of questions. It'd be interesting to get information about it, but I'd be very worried about confounding the study with their bringing in different views as they look at something we're trying to have them look at it.
Thank you very much.
All right, next up we have Jeff Gerhard with a talk titled Ringers of Jupyter, the Jupyter Notebook as Faux Web App. It's Jeff. Awesome.
Let me get set up. Okay, I'm ready. So hi, thanks a lot for having me here today. I'm Jeff Gerhard. I am from Georgetown Law Library. Please let me know if you can't hear me or anything like that. I proposed the talk today with the title that you see here on the slide, but in developing it, I thought of a title I like even better, which is Exposing the Ductwork. By the way, all the photo credits for what I'm doing today are at the end of my slides, but there's one non-free image that I'm going to highlight because I asked for permission to use it specifically. And also, I wanted to mention that, you know, I am not a programmer and I am not a developer, but I'll be talking about code in the way that I use it in particular. I'm not in presentation mode. I thought that was automatic.
I'll mess it up, don't worry.
When I did it earlier.
Yeah, you got it.
Am I good? I got it. All right, thank you guys. Cool. But you can look at my notes if you want. I posted them on my Twitter, and it's all available right now. Okay. So the background image here is of the Centre Pompidou in Paris, and that's something I'll be getting to later on. And I want to cover a lot in this 20 minutes, so I'm going to talk fast. I hope we can catch up later if there's more that we can talk about. In general, what I'm going to be doing is giving a brief introduction to Jupyter Notebooks. And then I'm going to talk about how I use them in a digitization project at my library. And then I'm going to engage in a little bit of extreme speculation about some socio-political consequences of using this type of technology. I hope it ties in with some other themes of the entire conference. So basically, for those who are not familiar with Jupyter, it's a way essentially to run code inside of a web browser. And it has a lot of great functionality, like displaying outputs of code piece by piece as you go through it. It allows you to interleave blocks of code and blocks of formatted text. And it allows users of the notebooks themselves to engage in a lot of interactivity. And this emerged originally from a Python-only project, but currently is available for a ton of different programming languages. The name is based on the original 3 languages it supported, Julia, Python, and R, and is allegedly a nod to the notebooks of Galileo. Here on the screen is an example of a typical Jupyter notebook. It's the first one that I ever touched and worked on. And they are used quite frequently for data science because they're really great for data visualization of graphs and tables. And as you can see, they They allow to have different blocks of text and blocks of code. They allow for a great deal of interactivity, like changing variables around and seeing what happens. They encourage literate programming, explaining what you're going as you work through code. And they skew heavily towards scientific uses, but they're expanding rapidly. Basically, Jupyter runs a kernel for a programming language such as Python, but the notebooks themselves are just JSON files that record the blocks on the page, their content, and their outputs. You can open them up and edit them in a text editor if you want to. You can manipulate them just like any other JSON file. You could generate them programmatically or make notebooks from within notebooks, sort of like a Jupyter inception. At my library at Georgetown Law, we're doing this project for which I turned to notebooks, and it's a digitization program in which we're digitizing microform stuff. And the particular case is US Circuit Court cases, records, and briefs. These are generally not available online, but they are public domain, so they are something that we're trying to get off of the microfilm and out to the public who might want to use them. We ran into a common problem with this type of project, which was that there was really no metadata to work with. And for microfilm in particular, we were digitizing film without even knowing what was on the rolls. So we had a lot of work to do to clean it up. What we're doing generally is to gather metadata post-digitization during the image processing phase, enter this into spreadsheets, use that information to generate unique identifiers, rename files, generate derivative files, upload these files to 2 separate digital repositories that have different specs, track everything in a digitization database, and also I want to hang on to all this metadata for some sort of future release or packaging or integration with an already existing free legal information movement. So there was definitely room for automation. We faced a lot of challenges, some of these that I just expressed. However, we also had some opportunities, including a labor force of student assistants who were available to work on this, a really convenient priority level in which this was something we wanted to have continuous progress on, but was never a high priority, and it was never my main project at work, and also a lot of freedom to experiment in a project. So why turn to Jupyter Notebooks? It's actually interesting that I did this for essentially the same reasons as what Emily Higgs from NC State was talking about yesterday in her great presentation. Originally, I did it mostly for aesthetics reasons. I was thinking about college students and how they'd probably prefer to work inside of a web browser rather than work with the command line, rather than work with batch scripts and things like this. And I thought that digital natives would feel more comfortable working in a browser where I could integrate procedures, documents, and links for them all within a sort of a web page. And on the screen, again, here on the left side, there is an example of an active notebook that I've been using. So I tried this out, and yeah, the aesthetics were pretty pleasing. I'll be displaying some screenshots of what they looked like, and these are real examples. We can integrate a lot of stuff in Jupyter Notebooks. It's really a cool platform, including having text blocks and code blocks, including images and graphics as part of the output. So if people change what's in the code, the images might change, including HTML and hyperlinks, and including tabular data through data frames. It looks really great. The process that I worked with to develop this was developing this stuff on my own work machine, deploying this on significantly less powerful departmental Windows workstations. That has a lot of implications. Implementing a form of version control, teaching students and colleagues how to use this platform that was new to them, and then profiting or something from this. So I'm going to go through some positive and negative outcomes from this project and then get to the political stuff at the end. The baseline is, yeah, I came up with something that works. It's pretty awesome. I made a functioning system that addressed our needs and did most of the things that I wanted it to do and had a fair amount of success in actually moving things off of microfilm and onto the web. I found that Jupyter made for a really nice user experience for me while developing and also for users. Is this working? I lost my screen. OK. And also for users who were navigating through it and actually running the code through keyboard navigation and things like that. Jupyter also is an emerging and fairly rapidly developing platform. There are new features coming out. There are ways to host this online. What I did was mainly working on local machines, but you can have hosted environments. There's something new called Jupyter Lab, relatively new anyway. That's sort of the current iteration of notebooks, which are even more app-like than the notebooks were previously, in which you can even launch them without browser Chrome. So it really feels and looks exactly like a native app, which is what I was kind of going for with this project in the first place. Another really great outcome from working with notebooks was a very much like a forced organization that I had to do. I had to think more concretely about what I was doing, make things more block-like, because that was the structure that came with the notebooks. I had to learn to manage code in reasonably sized chunks rather than have something like a huge line of code that was all in one thing that someone was supposed to activate. I made things more robust. The logic of Jupyter is that the notebook environment continues to run even if a single code block fails. So there was a lot of incentive for me to organize my things so that I could correct things. If part of my amateur code broke at the beginning, there were ways for me to go back and like continue and repair the damage that I was doing. And also, I found that there was a logic to the notebooks themselves in which, you know, this wasn't a website, it's not a web app in reality, but notebooks can be actually separate and discrete things that can be opened and closed separately. I can have a whole bunch of different notebooks that serve different purposes, and this was really a great organizational learning curve for me. Also, working with these notebooks helped me expand my notion of what is possible to do. They run offline if you're working with local code. This is awesome. I used them for an inventory project in an area of the library without Wi-Fi and was like, this is really good to be able to have something that's sort of like a program, sort of like a web app, but it runs offline. There are all these new cloud versions, and at my institution, we're already like so deep in with Google for good and for bad that I've been experimenting a little bit with the Google Colab environment, which is a Jupyter format run by Google. And I'd really love to explore using these more for things like dashboards and stats. There are a lot of ways to reach out to different web APIs or our databases that already exist that might have APIs, interact with this, and share them with my colleagues at a higher level rather than just sending this out to be something for tedious metadata work all the time, but actually have people use them themselves in our institution. So I want to also talk a little bit about some of the problems that I encountered in trying to deploy this on a bunch of random Windows stations at my library. One of them was all the different defaults and versions of Windows, which you guys may or may not be familiar with. Like, this is a screenshot of one computer at work that I was using that launched Jupyter into Internet Explorer by default, and I was like, does it work on Internet Explorer? I don't know, and I don't really want to know. Windows has all these things like user accounts and administrative privileges to deal with. It has virus blockers that might be like random on these workstations that really don't like either Python or Jupyter. And then I was wondering like who's really in charge of these machines. Even if I can install software on them as an administrator, we still have institution-wide IT that does things like install virus scanners or do automatic updates. They don't know that I'm doing this on the machines. I don't know what the implications really here are. There also were a lot of problems with Python when deploying it on Windows, as there's all these different installation methods and environments. There are module and API changes that happen all the time, including lack of backwards compatibility sometimes. I had no idea that bitness would ever be a factor, but 32-bit Python on Windows, at least, doesn't have the memory capacity of 64-bit Python. This is like great stuff for me to learn. In general, this project really made me rediscover principles that real developers already know. And I had a lot of experiences of saying like, oh, that's why they do it that way. And another problem was that the real world is a lot messier than code. Users are not always able to do what I anticipate just because someone like me has been using computers for decades, as you can see in this photo of me a long time ago. When I tell people just to hit Shift and Enter in a block of code to run it, they don't always really master the keyboard in the same manner as I expect. Metadata is always messy. My assumptions going into the project didn't necessarily match the reality of metadata of a reformatting project that took place decades ago that I was sort of recreating again. And I do have some concerns about the accessibility of Jupyter notebooks. It seems to me that Jupyter Lab has more accessibility features than the previous notebooks, and there are projects going on to make them more accessible. But this gets into a whole world of which I'm woefully undereducated, which is about accessibility of coding and programming in general, and I would love to learn more about that myself. The general takeaways from my project are, was this time well spent? And I would say for me, it definitely was well spent. I learned a ton of stuff. But for the institution, it's not entirely clear. I spent a lot of time on this, and a lot of it was relearning things that other people in this room have already figured out. I realized that aesthetics are not really all that important in this kind of a project. It looks really cool to do things in a browser, but it's the same amount of work as if it were not in a browser. And it takes just as much work to train people to run code there as it would if it were just a batch script or a Python script. There was a huge amount of work involved, and I want to talk a little bit about the respect for the work. But on the positive side, I think there are some interesting ways in which this is an educational experience, not just for me, but potentially for a lot of other people. And so I promised I would get into some talk about culture and politics, basically, in the time I have left. And I don't want to overstate my case here. This is really speculative, but I came up with a lot of interesting points while working on this project. The background image here comes from the Paris 1968 protests, which were 51 years ago, when students and laborers came together to protest against the de Gaulle regime in France and the political consensus of mid-century France. It's well remembered, but not necessarily as a failure or a success, but as a turning point, as people were protesting against things like colonialism, Algeria, and Southeast Asia conflicts, communism, and fascism. I think we're maybe at a turning point like this again, where there's a lot of conflict and turmoil over technological, political, economic, and environmental problems. And if so, I think we have a responsibility to think about this stuff in our daily work. As a direct response to those 68 riots, Georges Pompidou, who was then the French president, arranged for a competition for a massive new cultural center that incidentally was meant to be largely a library, and there were librarians who were part of the jury for the architecture. The photo you see in front of me here is the famous Centre Pompidou. And the jury was looking for a linear, flexible, functional, multi-purpose, and simple design for this project. It sounds a lot to me like actually a Jupyter notebook. It might be a stretch, but they were looking for, or the architects themselves were looking to make a building that was itself an informative tool. So I want to talk about this technique of putting utilities and pipes on the outside, which is what they did at the Centre Pompidou. I've been thinking about the Jupyter method as a possible counterbalance to this trend of making things seem like they just work by magic. Because making stuff appear to be magic might just be another method of hiding the work and hiding the worker. I was really excited by yesterday's keynote from Sarah Roberts talking about invisible information workers, and I think this is an important thing for us to be talking about. So I want to talk about unburying our infrastructure. You know, even if you're not interested in HVAC systems or plumbing, it's good to be aware about infrastructure. I think that coding is becoming a utility, sort of like plumbing, where it's important, but it's not glamorous. But that doesn't mean we should want to obscure it. I think we should put it out in the open where people can see it, open it up, and maybe learn something about it.
You've been reading my talk.
No, is this coming up?
Yeah.
Well, I'm also ripping off yesterday's talks as well. Sorry about that. I think if it's hidden away, there are a lot of implications, like deferring maintenance, lack of funding, and externalities like environmental impact. I live in Baltimore, and we have a multi-billion-dollar deferred maintenance in our sewer systems, such that a couple years ago, they had to literally run above-ground sewage lines in the downtown, a place that was already economically reeling as people from the suburbs were avoiding the city following the 2015 uprising. I think maybe we can head off some of those cascading problems through thoughtful education and being mindful about the things we choose to hide away. And anyway, I think there's a value in friction, having people look at code as a tool instead of as a magic wand. Michael Edwards, among many others, has talked about how friction is essential for social change and politics. We don't have the same values, and that's why we have politics. A world that doesn't have friction is not a world that's political. Being apolitical is only a good thing if you're already winning in the system. I read a really good piece a while ago by Rina Nikulu talking about an online beauty brand that echoed the imperative of the tech industry, having minimal fuss and working to be forgotten. You know, she talked about this perfect makeup that was invisible and was an online brand, and that in order to sell a product, you know, there are all these forces that want our technology to be invisible. It reminds me a lot of yesterday's keynote where Sarah Roberts talked about a content moderator who said that the sign of doing a good job is to leave no trace at all. I think we in this room are a group that can work to expose the ducks. And reading Nikulu led me to read Olia Lialina, who I really recommend. And this is going to help me circle back around to Jupyter Notebooks again. She talks about the general purpose user of technologies, someone who can actually use the technology in their own way and not in the way that people necessarily intend it to work. And I want to think more about this, empowering users to use technology in their own ways. You know, I'm not the only one in this room who used to do a little bit of web design work in the old days when you could look at HTML source code and learn how to do it. I think we've lost those entry points to technology as it's become over-specialized and incredibly complex. I think we need those entry points where people can like change a line of code or write something in text and see something cool happen. Jupyter Notebooks are kind of a way that people can do this. I know this is stretching the point. My photo here is of exposed brick, and I can look at exposed brick and it doesn't make me want to be a bricklayer. But I think it's good to know about bricks as well. Those 68 French protesters famously wrote poetic slogans about the paving stones that they hurled as weapons. Just like those student protesters, I think we need to take what we have at hand or what we do at work and see what we can do with it. We have power and responsibility as technologists of some type. And I don't think everyone needs to learn to code, but I think everybody needs to know some things about code, especially that it's human-made and it's ultimately comprehensible. So just to recap at the end, I think we just need to think about how that the ways we create, use, and understand technology have far-reaching consequences. You may never use this exact same technology yourself, like Jupyter Notebooks, but I hope we can all work in ways that emphasize the autonomy of the users and transparency and our educational purposes. Wrapping this up, these are some of the sources I used in coming up with my ideas, and these are photo credits. And we may not have time for questions, but you can reach me on the internet through these methods. Thank you. I'm sorry if I stole anybody's ideas for later presentations or talks.
Actually, it's awesome.
All right, cool. Is there time for questions? I have 20 seconds on mine. No? Okay, thank you.
All right, some more announcements. Lightning Talk signups for tomorrow are available now in the usual place by the registration desk. And I have breakout session to announce here. Let's see if I can figure this out. Sorry, guys. We're gonna get there. Almost there. Here we go. That. All right. The day 2 breakouts are Code4Lib. Well, you guys can read them up on this, maybe. Can you guys put that up on, can AV put that up on the screen? I'll read them.
We're going to exit Jeff's talk.
Okay. How about that? Nope. Yeah. All right. So I'll read them real quick. Code4Lib 2020 host proposals. Join the 2019 LPC, Concentra, and the 2020 host voting committee to learn about creating a hosting proposal and running the conference. That's in the San Jose room. Regional Code4Lib groups. That's in the San Martin room. Working with archive space, that's in the Monterey room. Achieving privacy in the age of analytics, that's in Santa Clara. Where we here, group meeting in the lunchroom, Speed 2, the mentoring in the lunchroom, and front-end design systems. in the lunchroom. And those are the breakout sessions. And we have a poster session following the break after the breakout sessions. And then we have some more 20-minute talks after that. But right now we have breakout sessions starting now. So